Hey Allie, we're back, and I'm going to give you two functions. One of them has an inverse function, and one of them doesn't. So let's see if you can verify that. Take this first one, and I would advise just putting it in the calculator and seeing if the inverse actually, I guess I have to give you a little more about that. Let's go ahead and find out what the graph is for this. Since I'm taping, I won't pause. The graph for the first one looks like something like this. It goes up, down, and up. And when you check it, instead of reversing x and y, solving for the new y, graphing that, and seeing if it's a function, there's a quicker way. So, and what we can do with this is see if it passes the horizontal and the vertical line test without even finding the inverse, just if the original function does that. So this one passes the vertical, but notice it fails the horizontal, because the horizontal line test says it passes at no more than 1 point on the function, any horizontal line. So right here, it fails. So this one's inverse is not a function. All right, this one looks like this. Very similar looking to this one, but there's less wobble. See where there's a big wobble there? Here it's a smooth transition there from concave down to concave up. So, Bailey, what do you think about this one? Does it pass both?
Yes.
It does. So, technically, I should have you test whether this has an inverse by actually creating the inverse and graphing it and seeing. But I don't want to spend all the time on the on that part of it. I want to move on to the calculus. So if the directions in the book ask you to check if it has an inverse, and then if it does, continue on, all I'm asking you to do is look at the original graph and eyeball it. All right, so let's go on and change the title here from inverse functions to derivatives of inverse functions. So that's where we're going to land today and spend our time. And this is one of those topics, if you get it, this is like easy peasy. And if you don't, it's kind of like labor. So let's just go ahead and assume that we're going to understand it. I'll give it my all. All right. So graph for me a function. This one actually is the ln function, but you don't need to know what it is. And reflecting that across the line y equals x, we actually get e to the x. I don't care what the function is though. This is typical picture of a graph and its inverse. Do you agree? Mm-hmm. All right, sketch that. Because I have to make two important, almost amazing observations. And that is, say we were on this graph right here, and I call the point that I identified there on the original. This is the original. We call it f of x. And I'll call this f inverse. 3 minutes left? Wowie, wow, wow. Okay. All right. So we'll see how far we go in 3 minutes. Here we have the function f of x, and here we have its inverse. I would like you to realize that if AB is on this graph, the mirror point across the line y equals x is BA. That's probably not too shocking because in algebra, when we actually found the inverse, we exchanged x and y. So can you swallow that? Mm-hmm. If AB is on the original, BA is on the inverse function. Then look at the slope. The slope of this, if it's say the slope is, I don't know, 1/2. After drawing all those slope fields, you can just visualize slopes so easily. So guess what the relationship here is? Is that steeper or less steep?
Much steeper.
Pardon?
Not
It's sleep. Pardon?
Super.
Right, okay, I thought that's what you're saying. So it actually happens to be actually reciprocals. So this becomes 2. So that works the other way. If this was really a very steep one, this wouldn't be. So they're reciprocals. They're not negative reciprocals. The sign stays the same. All right, so in calculus class today then, here's the type of problem we'll do. Find the inverse derivative of a function. Find the inverse derivative. Here is the lingo. It's f inverse with a little prime symbol. So you have f inverse prime of x. So that is saying the derivative of the inverse. And here is the function I'm interested in. And I am interested in finding f inverse prime of x at x equals 26. That's the tricky part, is not this problem, but this x equals 26. Can you see the way this is worded? That I am talking about the x value on the inverse function. In fact, your book won't even say x, it'll say a, just so you're not confused of what value they're talking about. So this is talking about the x value on the inverse function, which is what on the original one? Really? I don't have to call.
26.
I don't have to call on you today. If this is the x. All right, we ran out of time to finish this problem, and that puts you in a spot where you really can't do all the homework. But what I'm going to assign is just tell me if these problems, if their inverses are functions. So we have gotten that far. So that'll be part of our work done. And that is 5.3. And if you could shine a light on that for me. 5.3. We're going to do all of these. They start here 71 and they end over here. I guess that's 80. So if you could, Bailey, shine a light on this handout for her. And it's 71, this section right here. I'll circle it in chalk because that's what I have in my hand. And all we have to do, ignore the directions that the book is, all we have to do is ask ourselves, do these have inverse functions that are functions? And that'll set us halfway, half of the work will be done. All right, Allie, that's all. Hope you're back with us next time. And here's the assignment.
Okay. Think she can pause it?
Yeah, it's 71 through 77 there. You ready?
Yeah.
And the top 3 there, it's hard to see their numbers. It must be 78, 79, and 80. Oops.
Okay.
All right, over and out.
Bye.
Okay, thank you, Allie.